Hello. If you're watching this, you missed day 2 of our week 8 Foundations of Technology lecture. Let's get started. This fine Friday or Thursday, we talked about isometric drawing. We kind of finished up that assignment, number 15, that we started last time, and it's due Friday the 23rd by midnight. And we started on assignment number 16, orthographic projection, which is our next topic in order of business. Your objectives are to create isometric sketches. Hopefully you're feeling pretty comfortable at that by this point. Create orthographic projections, which we'll be working on moving forward into next week. And ultimately, we're not quite there yet, but we want to get to the point where we can construct three-dimensional models based on our orthographic projection. Alrighty. So real quick, let's do a recap of last class in case you need it. I think a lot of people were a little bit confused in assignment number 15 and needed some help. So if you're one of those people, here's a recap of last time we talked, which is this idea of how to draw in this isometric space on this isometric graph paper. The most important thing is you want to envision a box around your shape and then use that to help you assist filling in the rest of it. So step 1 is we need to figure out how large to make our box. You can think of your shape as being composed of little blocks, and then you want to figure out how many blocks in each direction do we need. So if we're thinking about length, that's going this direction along this diagonal, we would need 3 boxes at most. If you're talking about depth, that's going this direction, you would need 2 boxes at most. And height-wise, going straight up and down, you would need 2 as well. So these are our dimensions. We need to keep track of them. And we need to draw our box. Let's go ahead and do that. So it doesn't matter what side of the box you draw first. I chose to draw the right-hand side, but you can certainly do the front or the top first if you like. I picked a reference point to be the start of my shape. In this case, it's right here. And we'll go 2 units up and 2 units deep to create the right side. Then I drew the top by going 3 units in length, going back this way. And last but not least, I filled in the front. I didn't need to measure anything for that. All the information was already there from our previous measurements. All right, next order of business is to draw all the parts that are touching the actual faces of our box. That could be edges, could be points, could be actual faces on our object, which is the case here. So I'm going to draw this top bit because it's touching the top of my box. So these 2 squares are right here, and I can outline them. There's a point, or actually 4 points, and the whole face over here on the front as well. So I'll draw that next. And last but not least, there's one on the right. After I've got that, if I'm doing this on paper, usually I'll outline them in a heavier, darker color so I don't get them mixed up with some other lines that I'll be drawing in a moment. Next, I want to go ahead and fill in the edges that connect these faces to other places. So that's up to you how you want to do that. I like to go from the bottom up sometimes, or in this case, I like to work in from the faces inwards. And I'll do all of my lines that are going in the depth direction first. So that's these guys and this one. Then I'll do all the ones that are going in the length direction. And last but not least, all the height lines. Once I've got all my lines penciled in, I want to outline them in a heavier tint. And voila, that is my whole shape. All right, so fair enough. Now let's go ahead and talk about our new topic, which is orthographic projection. Orthographic projection is another way that we can use as engineers to convey our ideas to the manufacturers. Sometimes an isometric drawing by itself is not enough, or it would be too crowded with annotations if we tried to put every single measurement that we need to include in there. So what we would do instead is something like this. Notice all the measurements are present, and they don't crowd the picture in any way. They're nice and off to the side, and they tell us exactly the specifications for each part of our shape. Now, how do we create these drawings, and what do these even mean? Let's talk about it. So every shape has a length, a height, and a depth, right? When we draw it isometrically, that's the 3 dimensions we're tracking. Well, if we were to look at this shape straight from the top, as if we were a bird, what would we see? We'd see this part and this part. We'd also see this edge, but we wouldn't really be able to tell what's going on there. I mean, we know right now that this is a slant, but if we just look straight down, we wouldn't know if this is rising up or rising down, or if there's a curve there. All we know is there's some kind of change right here where there's an edge. What we could do next is we could turn that shape like so until we're looking at it straight from the front. Notice the interesting part that is important to note here is this dimension, the length, stays constant. It's the same shape, so the length doesn't change. So the length, this dimension, and this dimension stay the same across those two drawings. Next, we could turn it the other way to look at the shape straight from the right. These are the three orthographic projections we'll be working on in this class. Now, there are some dimensions to take note of here. Length stays constant between the top and the front views, while height stays constant between the right view and the front view. Depth also stays constant, but it's a little trickier to show that. Depth is constant between the top and the right side view, and if we were to draw straight lines from both, they would meet at this 90-degree angle right here. And this dimension should be exactly the same as this. And if we draw a 45-degree line, it should pass through both of these exactly the same way. So that is one way you can track depth. All right, so the best way to understand what's going on here is imagine the object is inside of a glass box. We're going to take that object and we're going to outline the points that we can see on that object at the edge of our vision if we were to look straight at that glass box panel. Then we draw some projection lines. Projection lines are imaginary lines that are used to locate or project the corners or edges of a three-dimensional object onto this two-dimensional surface. So let's go ahead and do that. If we were to project it this way and connect those points, we would get this projection, which is the front projection of this shape. Let's go ahead and do the same thing, but for the other sides. So if we encase our object completely, on the right-hand side here, we get these points. And if we project, there's no way to tell what's going on in this top box, even though there's a huge slant. There's one way to know that if you just look from the right. All right, and then from the top, the shape looks like so. Ta-da! That is orthographic projection in a nutshell. We'll be doing a lot more with this next week, so if you're not quite there yet, don't worry. We're going to do a lot of practice in class. It's really important that you show up. All right, here's some examples of orthographic projection. And if you were to look at these shapes, what is the same among all of them? Well, they all have the same dimensions, but more than that, if you were to take a top view orthographic projection of all of these, it would look exactly identical, despite the fact that they are radically different. So this is a slanted surface, over here it's flat, over here it's slanted in a different direction, and over here it's rounded. From the top, there'd be no way to know. All we would see would be these two edges that are present in all these drawings. We'd have no idea what those edges meant. So there's something kind of tricky about these projections in that we need all three of them in order to get a full picture of our shape. With just one, you could be easily led astray. Let's take a look very quickly at our assignment that's coming up. This is going to be due next Wednesday. What are we doing here? For this first bit, you have to find out where each surface is on each of these projections. So I did the first one for you. A is over here on our isometric drawing. On the top, it's the number 9. From the front, you can't see it, but number 3 is pointing to where it would be. And from the right side, you also can't see it, but once again, 21 is pointing at where it would be. You have to do the rest of these letters. The rest of this assignment, I will go into a lot more detail with on Monday, so you can try it. But if you're having trouble, don't worry. I will be going into a lot of explanation for this starting Monday. So I hope to see you there. Thank you all very much for coming, and have a great weekend.